There's a fingerprint lock on the door.
Hello everyone, it's me Vyna and my friends Fabiano will present you about utilizing printer ink for organic ink. Before jump to the topic, allow me to tell you about inkjet printers. So as we know that inkjet printer is the most commonly used type of printers since the 1908. This is the type of computer printing that recreates a digital image by providing the flash of ink. Here is the basic thing that we should know before we continue for the main idea, starting with varnish. Varnish is a clear liquid that solidifies as a thin film. It's been the filament to the printed surface, provides the printability of the ink and wets the pigment particle. Second one is resin, and term are firmly binders, and they bind the other ingredients of the ink together into a film and bind it to the paper. And the third is solvents. Solvents are used to keep the ink liquid form when it is applied to the printing plate or cylinders until it has been transferred to the surface to be printed. Then pigments is the color of the ink, and pigments can also provide glows, absorbance, and resistance to attack by light, heat, solvents, and other. And the last one is additives, and many different types of additives are used to alter the physical. Here is the condition when you want to produce the ink. Another addition feature for the last part, the last step of production ink. Take a closer look of the ink, and well, the ink is a combination of ingredients such as varnish, resin, solvents, pigments, and additives like I mentioned before, and usually they will use titanium dioxide, and these components are aggressive to the nature and that might cause harm to several species. So our main idea is to change those.
Patterns are really different from each other. There are so many kinds of fingerprint patterns, plain arc, tinted arc. All of them are specific from each kind of person. And our kind of people got a specific kind of fingerprints, so it's unique since every person is unique. So how can you replicate this? So the point here is we're going to talk about the article that we found, which is the solution from our problem. But first, we got to find what a fingerprint pattern has to do with it. A crime scene investigator, when he's trying to investigate a murder, it needs a fingerprint in order to connect the suspect with the crime scene, and then it can be compared on a database to find exactly the person which was there. But it's really difficult to find exactly the person because sometimes the ridges or actually the current flow towards it does not give exactly the same ridges or same pattern that we need to find on a database. But here's the problem: how can you replicate a fingerprint from a human being? It's really difficult because all the ridges connect some kind of current as well, and you cannot print it on a paper, for example, in order to unlock a device. But how can you do it? How can you replace it? That's a solution. Well, every kind of fingerprint got a specific current flowing towards it because of the ridges as well. So since our skins can conduct some kind of electricity, it's a really specific pattern conducts toward the ridges a specific current, and then you can unlock a device. But how can you replace it? Well, the point of all of this discussion is that we found a specific way to replace the printer's ink. And what's the fingerprint has to do with it? Everything. So the Institute of Massachusetts found a solution for that. They were inspired by a real fingerprint creation or with organic compounds from the CIA agents, and they created a fingerprint from a human being that can unlock any kind of devices. You just need one singular fingerprint in order to do that, and then can replicate as many times as you want with a printer. Yes, that's going to blow your mind. We have the carbon nanotube ink. Yes, exactly. We are replacing the printer's ink with a carbon nanotube ink. It's really impressive. So on the top picture, you can see a real person's fingerprint. At the right side, you have a carbon nanotube fingerprint. And all the carbon nanotubes are attached together and scrambled in order to create all of the ridges, and all the ridges create the same pattern of current or electric current as well. And when we have on the right side, on the bottom picture, you can see the fingerprint sensor, and the fingerprint sensor creates exactly the same current, and it flows around the printed fingerprint all around the ridges from the carbon nanotubes that can conduct electricity, as the article that we found said, and you can unlock a device sensor easily. It's really easy to find some kind of solution for things, but this solution we proposed because the carbon nanotubes ink can unlock a sensor device easily as many times as you want. We just need one real fingerprint. Well, I'm going to talk about the Cnt ink. Well, as you can see, the diameter of the Cnt nanotube is less than 50 nanometers, and also all of the spreading and all of the Cnt was placed here on SAM microscope in order to see exactly the diameter and the length of the carbon nanotubes as well, and how they scramble to each other in order to create that pattern that we talked about before.
Here is a note that underline it. They use same equipment, like I said before, to show the aggregated pattern of the fingerprint and show the distance between the ridges. As a reminder, if you forgot, SAM is a technique for physical chemical qualitative characterization of carbon.
The carbon nanotubes printed patterns were invented, which means that the fingerprint was printed many times, from 1 to 10 times. So the study showed that the surface profile of the carbon nanotubes printed patterns, their height is seen to increase approximately from 0.3 to 1.7 micrometers as the number of printers increase from 1 to 10. Because of the electrical conductivity of the carbon nanotubes pattern, it depends on the printed carbon nanotubes network, the conductivity. So the conductivity of the carbon nanotubes pattern can be improved by increasing the number of printers. Well, the printings are increasing by the printer's print, but the problem is the number of printings can cause an increase on the resistance. So the more you print, the less resistance you get, so you can conduct more. So it showed us that the surface sheet resistance of the printed Cnt carbon pattern is roughly from 3.4 kiloohms per square millimeter for the one printing, decreasing about 0.6 kiloohms, as you can see that for 5 times printing, and then it decreased more and more until 0.4 kiloohms. It means that if you print more, you increase the distance and you can create a fingerprint not as real as or as close as a real one. But the problem is, as you create or you increase the number of printings, you get more electric current flowing towards it. Well, in this image here, you can see all the patterns, all the ridges increase by the lenses of the microscope. And then on the first one, you can see the contrast, and then the second contrast. It's the same fingerprint. All three are the same. But the main objective here is to show very closely in contrast the carbon nanotubes patterns. They are not so aligned, but they create a very similar fingerprint pattern as a real person's. Well, when you talk about the printed fingerprint, so in this experiment, they use a capacitive sensor to work by detecting changes in capacitance across its electric circuit under the influence of a conductor on its surface. So in order to do that, you have an area and the electric constant as well calculated and calculated by creating this pattern of carbon nanotubes plate. So in order to do that, because the Cnt plate was charged with the free electrons at the moment of touching, at least the sensor's capacitance was clearly detected along the specific relatively small additive perturbation, which means that it worked. It worked and the Cnt could conduct that electricity. So on the later fingerprints, they worked as a capacitor, so the carbon nanotubes worked as a capacitor, and on the latent fingerprints had been printed from 1 to 10 times. Individually printed fingerprints were cut out by using scissors. So they cut it and they used each fingerprint on a spoofing attack in order to unlock the button of a smartphone, the Samsung Galaxy A5, so which had been programmed or pre-programmed with the owner's real fingerprint, and the result was really impressive. After this spoofing attack on the phone, they found that the fingerprints printed 1, 2, 3, and 5 times had been successfully unlocking the phone. This is really impressive. It means that we can unlock it and create on a paper. In a simple sheet of paper, we can use a Cnt ink. And the more we print, we gain a width, and this width can conduct electricity enough, working as a capacitor in order to unlock a phone or any device. So here the point of this project was in order to create a new way of printing and also replacing the regular ink that is really poisoning by another ink, which is a carbon nanotube ink. So our team created a new way to conduct electricity, but we created a new way of printing on the paper so we can replace it with a carbon nanotube ink, which is organic and is less poisoning to nature. So we propose a new solution. Instead of using the regular poisoning printer's ink, you want to replace to another one, which is the carbon nanotube ink, which is going to make a great difference to humanity.